Hello there. Today I'll show my modified version of my timer from the mini project. As the coordinate system and a little bit of animation has been introduced this week, I thought now would be the best time to show this. So let's begin. Let's launch our timer. Pressing the start button starts our timer. Pressing the stop button stops our timer, but we'll deal with that later. And hitting the reset puts the hand back at its initial position and also stops our timer. Clicking the lap button adds a lap time over here. So as you can see, it's a lap time of lap number 1. Let's hit it again. Lap 2, 25.7, lap 3, and so on and so forth. You can also split the timer by hitting the split button, but first let us clear this first. Okay, the clear button clears my lap time and also stops my timer whilst returning it back to my original position. Okay, we will start it once more. My timer has started. Let us hit the split button. That's a 5.3, split number 2, 3.7, and so on. Let's clear it again, or rather let's stop it. As you can see, our timer has stopped. Hitting the reset puts it back, and now let's clear our timer. So this is it. That's the end of our program. Now let me talk a little bit about the sine function. Now what is the sine function? If we have a right angle triangle like this right over here, then taking the angle as theta, the sine of angle theta is equals to the perpendicular by its hypotenuse. So sine of theta is equals to P by H, as from this diagram. Now keep in mind that if I have another right angle triangle but with the same angle like this, okay, somewhat like this, the angle here is the same, also theta. Still, the sine of the angle remains same. Plotting the sine graph gives a wave which has its peak at 90 degrees and also at 270 degrees. From 0 to 90 degrees it increases till it gradually stops at 1, then descends to 0 at 180 degrees and continues to do so till 270 degrees. It again climbs till 360 degrees, and this completes one oscillation. Values greater than 360 degrees acts the same like before. It increases till the peak, goes down, touches 0, and again goes to the minimum height and then reaches the 0 again. As the angle increases, we will get more such waves like these. Multiplying a variable, say r, times sine of theta will give me an oscillating value between 0 to r, r to 0, 0 to minus r, and minus r to 0. Previously we had the values between 0, 1 and minus 1. Using this formula we obtain the important code that will be required to draw our hands in our timer program. Moving on to our code, I'll now show a demo of my second hand and how r sine theta is used over here. As you can see, if you notice, it's already used over here, but I'll explain that a little bit later. Also note that I have increased my browser space by zooming in, and I hope you guys will be able to read it. Launching our program here, we get something like this. We have three circles over here, one for the X, one for the Y. The X will move periodically like this, my Y will move periodically like this, up down, and our third circle over here is the combination of the position of X and Y combined. My line over here, which is the implementation of my second hand, is between a fixed point and the position which is followed right over here. Now moving on to our code, I import simple GUI and math. Now we have our global variables angle equals 270 degrees. Angle equals 270 degrees indicate that my hand will start at the 12 o'clock position. R equals 100, that is the length of my line. If I change it to suppose say 65, then the length changes. Okay, now we have our X position and Y position equals 0. We will initialize it in the pause function, which I'll talk about later, and my second variable, which is equals to 0. Okay, now we have our timer function over here. Create timer for every 10 milliseconds. It will call the function tick, which is my timer handler. So moving on to over here, for every ticks we will increase our sec value by 0.01, our angle by 0.06 in degrees. And now this is somewhat an optional code, because which states that whenever my angle is greater than 360 degrees, my angle should subtract it by minus 360, so that if I have a value called says 361, then it will give me the value 1. This is because I wanted to implement right over here, when my value over here will be equal to 360, I wanted to reset it back again to 0 and again count from 0.1 and then onwards, which you might be able to see in a moment. And then it will call the pause function, which I'll explain right over here. Now as you can see, my angle got reset back to 0. Okay, now let me close this and let's move on to pause function. Global X and Y, this will affect our variables over here. Now this is the most important part of our code. If you can remember, I've explained R times sine theta. Theta is just nothing but the variable angle, which I've mentioned over here. Our math.radians function is used to convert our angle from radians to degrees, because whenever we implement math.sine angle, it will give the sine of angle which is in radians, but we don't need that, we need it in degrees. So we use this function as needed. For a y value, or rather variable, we use r math sine math radians 90 minus angle. Okay, now we will move to our draw handler. This draws three circles which I mentioned. This is for the X, this is for my Y, and this is the combination of X and Y combined, and draw line follows the third circle. Okay, now I will just comment this section off so as to explain my code over here. Let us draw a circle which will draw in the position 0, x plus 150, 10, 2, my color code is green. Let's see what happens. Well, nothing happens like that. Okay, let me see what is the problem. Okay, it's actually moving, but I cannot see the difference much. Let me increase my timer and let's play it again. I should somewhat use a faster position, maybe like tick equals 0.6, and then okay. As you can see, it's somewhat jittery, but you can very well understand that it's oscillating, bobbing up and down, up and down. But we want this to be at our center, and so we put our value as 150, and hence it starts right over here. Great. Now let us implement our second angle, or rather circle. Canvas dot draw circle y plus 150 and 0 this time. I'll change it 10 comma 2. Oh my god, 2. Color code is green. Let's hit it again. Okay, now we have two circles. It's bobbing over here in the y direction, and if I change it to 150, then this will bob right at the center. Okay, so as you can see now, if you remember, the sine function moves somewhat like this. Up hits the 90, down 0, minus 90, or rather minus 1, I'm sorry, and it goes on like this. Okay, great. Now let us implement our third circle, which is a combination of these two. Forgive me for the spacing, but I'm just typing it. Oh, great. Now, as you can see, this circle, the third circle is actually revolving around a point right over here. Quite imaginary. And now we will draw our line, which will follow this from our center right over here. By doing this, I draw a line which will follow this point over here and from this point, and this is what we are going to do for our timer hands. I hope you have understood how to animate a rotating line. We can implement this in our timer program to create the dials of our timer. I have two links, one for the rotating line demo and the other is a fully finished timer. Do check these two. This is Ishan and have a great day.